Accepted.
Okay. Hello everyone. In today's session, I'd like to talk about the quality in infrastructure as a code. So before we go into the topic, maybe a few words about myself. So I do have quite a big experience in the DevOps. So even I started when there was no such a thing like a DevOps. I work in some big tech companies like Samsung, Boeing, NXP, if you know it. Then I moved or start to work with some clouds. So first build a few private clouds. Then it's been changed to the public with a trend. So I've been involved in quite a few migration from the private to public and so on. And then later on, I also had quite a big experience in the cybersecurity. I worked for the Emirates government to implement them some security systems for their needs. I spent a couple of years in the Middle East. And within that, I also, and right now I'm leading some DevOps team, security, or the support team, and so on. Currently, I'm working in the great tech company. We do have a very nice boost on the first floor. Maybe you see that one. So just a few words about the company itself. It's an iGaming company, so it's a little bit of a better word for the gambling. So we do provide the platform for the operators like STS in Poland, for instance. Actually, it's not our client, but just for you to understand. So we do have we are delivering platforms like casino, online, or sports books. So that's what we're doing. And if you are interested about the company itself, meet us at the boost. So as I said, today's talk it's about the quality and the testing in the infrastructure as a code. So at the beginning, I will just introduce you what's that. If you're not familiar with that, with the topic itself, and then we go with some example and the tests which should be, in my opinion, implemented. Yeah. And at the end, I hope we'll have a few minutes for some quality or questions, not equality. So first of all, infrastructure as a code. I don't know how. Just for me to understand what's the audience to, who are using any tools like a Terraform, Ansible. Okay, so good audience, so thanks. So as you probably know, so the infrastructure as a code is wants to meet or simplify our life with automation. So instead of doing a lot of manual and repetitive tasks like a deployment, there are a few tools which can help with that one. So that's the aim for infrastructure as a code. And there are quite a few tools, like I said, Terraform, Ansible, C Chef. Oh, that's maybe not a good example, but still a Puppet. So there are a few on the market. So hopefully you know about that. So then just a different slide, or it's not about the infra, it's not about the DevOps. Actually, a little bit about DevOps itself, because the very first thing, if you look into Google and start to see what the DevOps is, you will see the SDLC. And DevOps just with that move, they want to realize or just implement a flow of a standard development flow. So starting from the analysis of the requirements, then defining, design, coding, and so on and so on. So that's the for a typical life cycle talking about coding. But from some reason, the same guys, DevOps, are not following that one. So they design the flow, they design a very nice cycle, but no one is actually doing the same in the DevOps. What does it mean? So let's take an example that we'd like to deliver or deploy some service into the cloud. Of course, we do have some requirements. We're defining, sometimes we design, or actually that's also a missing element, but will not talk about that one because I saw quite a few kind of a justification from the guys. So when talking about the design, they said that we do a Terraform and that's our design. That's actually not a design, but that's a different story. But the speech, today's speech, is not about that one. It's actually about the testing itself, because what typical in the DevOps world, what we're doing right now, it's a coding and then straight away to the deployment. Sometimes it may work, but unfortunately, it's not like that you deliver something and it will work forever. If it's the case and there were no issues, I guess I would be jobless and a few guys there as well, because there are still some incidents, some issues. So that's the reason why the testing part is so important, but still, from some reason, it's very often omitted in that cycle of the infrastructure. So saying that one, so for infrastructure, when we're talking about the implementation, for infrastructure, it should be exactly the same as for the typical coding. So starting from the definition, and then each one of the elements should be there in that cycle. So why the tests are important for us? So first, it's about the reliability. So I guess if you're working with operation, with a DevOps, you saw quite a few different cases that something been broken from some reason, and that's a nightmare, especially if you have very high SLAs for the clients, and then if incidents happen, and they used to happen during the weekend and during the night from some reason, that's kind of our nightmare. So we'd like to build a better quality just to avoid or improve the reliability of our infrastructure. And maybe just a little bit of going, what do I mean by the infrastructure? Because someone may interpret it differently. So in my case, so what I do understand, it's let's take a kind of a typical stack. We do have a cloud, so that's definitely the infrastructure part. I'm not talking about the on-premise there, but actually it's scalable, or it can be implemented there as well. But let's take that part. So we do have a cloud, so that's definitely the infrastructure part. All the EC2 services and so on. There is typical some database. There is some message broker. There is a load balancer, and so on. So those and some DNS records and so on. So all of those, from my kind of interpretation, this is infrastructure, maybe not necessarily the services which are typical you deploy, but also that's should be somehow the part of the tests. But when talking about the infrastructure, I mean all those not kind of a company IP services. So all around that. So that's what I said about the reliability. The second important thing, why do we need the test? It's efficiency. So it's just a kind of a standard automation. So if we do the tests, we don't necessarily need to implement it once more or run it again and again. So just to simplify that, to be more efficient, we'd like to automate that one as well. So we can, whenever we have a tests automation or implementing some quality on one of the infrastructure component, we can easily copy that one to another one. Second one, it's about the security itself. So, and I will talk about that practice as well, because in some of the cases we can still do a little bit, maybe not, or it's actually, I have some, I will talk about that later. So, but anyway, with some measures, we can improve the security. So of course it's not, you will not be covered if you have all the tests it doesn't mean that you are perfectly covered for all the known vulnerabilities, and it will prevent from any attack. It's not, of course, not the case. So it's not just one thing which you need to implement. Of course, there are a few more security controls which need to be implemented. So, saying that, so what are those tests and how we should do that one? So first, and it's also very typical to a classical coding. So when you have, and with a test-driven approach, you have a piece of code or element, and then you need to define the test. So in some of the cases, it's not definitely natural at the beginning, and I will tell about it later. So you need to define those tests and help the team to understand what do you expect and what kind of tests should be implemented. Then a part of the static analysis. So that can be implemented easily. So on your computer, you're running some local scanners, the same as with I don't know, Clockwork or Coverity, those tools which you have for decoding. The same we do have for the infrastructure. And then later, all the tests, and I'm talking about the unit tests, integration tests, availability tests, and so on. And lastly, what's important to have to add all those tests into your observability platform. So because what may happen, it's not that you deploy it once and it will work forever. There may be some conditions which change. Someone may add the change by themselves or manually break something, or they may be some additional condition from outside which make the service unavailable. So that's there are a few actually things which may happen there. So that's the reason why we should still continuously run those tests whenever you have it. So going deeper to the topic itself, so because just saying that we need a test and there are some tests, it's nothing very valuable. So what I'd like to bring is just focus on those tests and possible implementation. So first of all, as I said, on your local laptop, so if you're using a Terraform, what you can do, you can do or run a static analysis for that one. So there are tools like a TF-scan. It costs nothing, I would say. So that's the open source tool. You can run it, and ideally you can you should implement it as a part of the pipeline. So what do I mean? So whenever you have a merge request, for instance, or pull request, whatever you have, then you can add to your GitLab some quality controls that, for instance, no critical nor high vulnerability issues should be presented in your code, and that actually resolve quite a few security issues. So even I read because no one measure it, but I read some article which says that it may eventually reduce by 70% of all the security events. So that's quite a lot. Is it true or not? But that's what I read. So when talking about the security, what kind of things it can discover? There are a few. So lack of encryption, some wrong policies, secrets which are presented in your code. So quite a few things from the security point of view. Also from the operational point of view, like not wrong tagging or lack of tagging also of your resources, or information about the oversize or unestimated. Lastly, some inconsistency either in the dependency regions, as well as a little bit of feature for the performance. So that's what you can implement. And as I said, it's a very easy step, but it provides a lot of value. So I really, really recommend you, even for your own, if you don't have kind of influence in some cases, you know, changing a deployment process in the company may be difficult. So even for your own, not safety, but quality, what you're producing, I would really recommend to use such a tool. Especially some of them are free of charge. Secondly, unit tests. And it's very similar to what we have in the coding world. So by unit tests, we want to put a quality control into very small piece of the either module or a service in our case, and we'd like to test that. And that test should be quite fast. I'm just put some benchmarks, so less than 5 minutes, because it should, or even less, I would say, because we'd like to, as I said later on, execute it quite often. And for instance, I use to implement a rule for there should be a unit test implemented. So why? So let's take an example for a bug. So of course you can fix that one, but just to prevent the very similar thing or the very similar situation to happen again, if you have a unit test for that one, you will ultimately have the alert for that event later on. Of course, if you connect that one to your Grafana or whatever system, Nagios or name it. So that's also a requirement to implement it. When talking a little bit more, so in use, or I see that it's not just one single test which can cover in most of the because I just sometimes it just either breaking. No, it's good. So what I see, it's just not one single test which cover everything. There are must to be quite a few tests to have a very good coverage. Of course, we don't necessarily need to test or verify if some managed services from Azure, AWS are working. So that doesn't make a sense and just waste of your time. So if, let's say, Oracle provides a database, you don't necessarily need to check the availability if everything works there. So just giving you an example what I do mean. And I just take some very simple DevOps tasks. So on the left, you see kind of a classical task to create a domain. Yeah. So of course you can do that one. So if you're using some infrastructure as a code, that's easy. So it's easier. You can just modify that in 1 or 2 lines in a Terraform, and you're good. And in most of the cases, unfortunately, it's deployed like that, and we're happy and move forward. However, it can break, yeah? It can break later on because someone changed the DNS record, someone, I don't know, make a typo, remove your record from some reason, stops to work. So one of the unit tests can be just as simple as a lookup for that domain if the domain exists. And then, as I said, if you connect that one to the observability platform, then you can constantly monitor that if that's still working. Additionally, the certs. And that's what I see quite also often, sometimes omit or that do not have inventory for all the domains. So it happens that, you know, suddenly that domain didn't, because the certificate is not valid anymore because it was 2-3 years ago and no one even remember that domain cannot be valid anymore. So if you add that test, and it's very simple, add it, and later on there will be no things like that. In some of the cases, if we're talking about, for instance, end-to-end encryption, you may add some additional requirements like ciphers and so on, just to make sure that you deliver what's supposed to be delivered. As well, just another example, some TTL for that record. So just another example to see if everything works there. Another example on another task or DevOps task, which you may see, just move one of those services. I hope quite a few, or one is using HTTP, and still there may be some. And as well, what you can do, you can just change the port on the HE project, for instance, and you think you're done. Not necessarily. The same thing. You may implement quite a few use cases for that one, just to make sure that everything works. So just to see that if it's redirect, hopefully you checked it by yourself, but still, why not to execute a test? Then about the ports, sometimes still 8080 may be open and it's not necessary or should not be there. So so just to check if the ports are not expose any services on that port. Lastly, what you can see, you can also monitor some status of that page or HTTP code for that service, just to make sure that the service is up and running, and still connect everything to the system. I mean, to the monitoring system. The second type of the tests, we talked about the unit tests. Here, and unit tests are focusing on the very small element, one component. Here we're talking about the system, so how that one particular component integrates with others. So that's a little bit more complex, but still can be implemented. You are, in most of the cases, need to have some dedicated environment for that one, because or still you may deliver or deploy few of those infrastructure components into your own laptop with your own Kubernetes, for instance. But in some of the cases, it's a little bit more complex, and you don't have enough resources on your laptop, so you may need some semi-production or test environment to execute those tests. And what's an example of those, and I may add even more, still one of the thing, a broker, a message broker, Kafka or name it. And just because of due to scalability, for instance, you'd like to, or someone want to add just another node. Still simple, add one more node, and you're good with that one. And still, maybe not necessarily. So you'd like to implement a few tests just to make sure that everything works there. So first, about the replication, just to make sure that actually it's a little bit about the high. And after adding that node or updating the node, updating the version of the broker, there may be similar things to that. So check all of those, the functionality which may eventually went wrong after you make such an infrastructure change. And also, point of view, it may also be some negative input, so you should also measure that one. Yeah. Another case, it's about high availability. So most of the services, name it as I said, either it's a message broker or a database, load balance, all of those have the high availability. But if I ask how many of you checked if that high availability is actually working, that's that's actually yeah, I would say that maybe not a lot. And that's also very important because I saw a lot of different cases that we do have, and everyone claims we do have a high availability. You know, the traffic went from one node to another because the first didn't work from some reason, and then everything's worked because the handover from one active to the passive didn't work well, or the passive didn't, or yeah, it doesn't work. So it has to be tested. It has to be tested in a few different ways. So first, failover scenario, just what you can do. Let's take an example that we have a active passive database, yeah, and we have a load balancer on top of it. Actually, there is no load balancer. No, different case, yeah. Two services and a load balancer. Like a problem, yeah. And if we service from the node, ideally the traffic should go to the node. But the answer, of course, should know the health check, status and the health check of those services. And sometimes we define them good, sometimes wrongly. And then if everything's, if all the traffic goes to the first active node, and then suddenly we'd like to pass the traffic to the passive says, yeah, I'm healthy, not. And then we do have an issue because none of the working nodes are fine. So what we definitely need to simulate that one. It's not very difficult, but still you need to implement those tests, like stop one of the backend node, see if the traffic goes to another one, and vice versa. Unlikely to the previous one, tests where you can execute it freely on any test environment. Here there may be some side because actually you will stop some services. So I really suggest to have some dedicated environment for that one where such a change with the services will not affect others. Also, it's very important to not forget to bring everything back, because if with a classic case, as I said, we would like to two backend services. First, if everything works on the first, yeah, we do opposite tests, check if everything works on another one, and we end with a stage that the first is running. So it's very good to test or all the services up and running as it was. Later, just to summarize, when talking about the quality gates, how we can implement that one, or how it's supposed to work. Just a classic pipeline, yeah? First of all, as I said, on your laptop, in your GitOps as a post commit, you add the static analysis for that one with quality controls that there is no critical vulnerability in your code. And ultimately, everything does not pass that one should not be merged to your development or main branch. Then the second one, the unit tests. There are a few approaches there. Either you may collect it, depends on the timing of those tests. If everything is quite tight in the schedule, you can even execute all the tests in once. So it's not very long, even half an hour. Then you can aggregate them and run before the merge, or post the merge. You can see depends on the size of your infrastructure and the speed of that one. Integration tests, as I said, and together with high availability tests, it's definitely something after you merge it, because it used to be some longer executing tests. And when talking about the quality, it's actually easy, because what I use, that basically everything or % of the should be running, because adding some tests which is not passing doesn't make sense. So you should target that every single test it's working, because if not, that there's actually some incident or something. High availability, as I said, you don't necessarily need to run it often. We do have even once implemented, we run, remember, once per month, which is enough, so you don't to repeat those tests very often. But still, I really recommend. You just don't really only rely that you have a high availability system, if it's the case. Taking all together, I want to describe, for instance, for one type of the task, what kind of tests you may have. So I talked about the unit test and blah, blah, blah. Here we have also a task, let's say, to set up some application load balancer into AWS. So with such a task, we may have a few different tests to be implemented. So starting from the left, from unit test, of course, static tests, but static code analysis, but more or less common for every single task. So let's say that you have already that practice and you execute it for every Terraform, let's say, change. So similar to that, similar case to that one, certificates, yeah, just to make sure that it's the certs are there, and also you may add some additional controls. If, for instance, if your services should not be exposed to China, for instance, you can also implement such a thing, because that's supposed to be implementation on the load balancer, and you may check that one as well. Then integration tests. Sorry. As I said, to check the health check of the status of all your services, and that's also connected to the failover test to simulate the failover from one node to another, and I missed one. Anyway, there was one integration test about the load, actually implementation of a good load balancing, because in some of the cases you still have a load balancer, but from some reason all the traffic goes to one node, not to another one. So you may check that one as well as the part of integration test, just to make sure that the load is spread equally. If it's supposed, in some of the cases maybe it's not your intent, but that's in most of the cases. Then going back to the failover test, check the primary, check the secondary node, if are they healthy, if they can pass the traffic. You may also define some scenario like I listed there about the availability zone. So that's one of the case. What can be implemented? It really depends on you, on your infrastructure. It's just ideas what can be added there. So just to summarize everything together. So first of all, those tests should help us to reduce all the human errors. As it's been said, there are quite a few cases that you deploy, you think everything works fine, but still there may be some forgotten changes or misimplementation. So that's really a good thing, similar to a test-driven approach. You add unit tests for everything just to protect yourself or make sure that what you implemented it's what it's supposed to be. Just to check if infrastructure as a code, if you're coding what you coded, it's actually what supposed to do. Because in some of the cases, it's also going back to requirements. You may misinterpret what someone wanted with that request. And if you have defined tests, those are like use cases for you, and you also may check if that one was what's really expected. And it's actually checking with the requirements if your requirements are met. Another point, it's about implementation or introducing that one into the team. So because I try to implement that one for a few different teams. So at the beginning, it's just kind of a not understanding from the team itself, why do we need it and how to implement that one. So I used to, at the beginning, to similar to the previous one, so with some possible test cases, just to list them. What's your expectation? How do you see? So let's say you create a task for the team, and then together with that one, you may set expectation, what kind of a test should be implemented together with that task. And that's also important to add, that it should be the part of the task, not just another task, because it will be, pipe in the backlog, and you have 2,000 tasks like that to implement unit tests, which will no one never do. So as a kind of a definition of done for the task or for a bug as well, it's not just a fix a bug, it should be adding a unit test for that one. So you need to change a little bit of mindset in your team, that you don't fix and forget or implement and deploy. You need to add something more. And as I said, I used to do it as a definition of done in the task. So each of the tasks, each of the bugs should have some coverage. Lastly, or maybe not lastly, one of the points, what I already mentioned, it's don't be crazy with that. So don't necessarily implement thousands of tests, which doesn't make sense. Like we have managed database in AWS. You don't necessarily need to check if the queries are working, because that's the service, and they claim that they have a 99.99 availability for that one. So why do you need to bother and create a test around that one? But still, when talking about the database, you may check or create some tests if I don't know, if admin as a login and password has been changed or not. But still, there are a few controls or a few things which you might check even with that managed services. And as I said, one and very, very important thing is to add everything to your monitoring platform, because running it once, it will reduce something. Of course, from the first point, you will reduce quite a few different human errors, but still, it doesn't mean that tomorrow it will work as it's supposed. There may be few factors which still may break your infrastructure. So it's very important to add either a Grafana dashboard or whatever, add to your platform all those tests. And then it ultimately helps operational team to identify what went wrong. Just to give you an example, yeah, we do have a service, and of course you monitor those services. You have some alerts around that one, and the operational team discovered that the service ABC stopped to work. But in most of the cases, that's end where can kind of dig why it stopped to work. It doesn't respond. And if you have those unit tests, you may give them a lot of valuable information why that service doesn't work. Is it about the domain? Is it about some networking? Is it about something else? If you have a very good coverage, all the incidents should be analyzed and fixed much faster than you have just a plain information that it does not work. So yeah, that's all. So few minutes for questions, if anyone have.